Good afternoon, respected viewers. So, in a lecture series, last lecture we will discuss about the what is automata and automata definition and fundamentals of the automata and applications of the automata. So, today lecture we will discuss about the automata examples followed by the some more contents, right. So, before going to the actual content, so today outline of the today presentation, examples of finite automata and transition diagram, transition table, example problems. So, we will start with the first examples of finite automata. So, first example, design and finite automata that accept the all strings over 0, 1 ending with 0. So, that means that finite automata it should start with finite automata that accept the strings over 0, 1. So, that means that the strings which is accepted by finite automata ending with 0. So, what are the strings? What are the strings? First strings is the 0 is a one string, it should accept, 00 accept, right. So, 00 it should accept, and one more thing also 000 it should get accept. That means that any number of strings ending with 0 it should accept. So, one more string is 0 1 0 it should get accept, right. And one more string 1 0 0 accept, 0 0 1 0 etc. These are the strings it should get accept, right. So, before that after that one we will discuss the some of the strings which is not accepted, right. For example, take the 0 1 it should not get accept because of string ending with 1, right. And again 0 1 1 it should not get accept, right. One more is 0 1 1 should not get accept. So, these kind of strings should not accept the finite automata. So, now one principle you have to understand here. First, how many, what is the basic string which is accepted? Single 0, right. Single 0 is accepted means must be automata with at least 2 states. How many strings are required? Minimum 2 states, right. So, for that one what we have to do? We have to take the one automata, right, one automata which is a starting state, one more state with the ending state, right. So, we know yesterday starting state will be represented by circle with arrow mark and ending state will be represented by double-ended circle. So, now you write the transition from starting state to the ending state which is given to the 0. Just I am trying a brute force technique here. So, there is no standard methodology to find the correct one. So, now you try single 0 is accepted, which is the first one is accepted, 00 is accepted, single 0 00 is not getting accepted. So, that means that this automata is partially right, but it is not a complete one, right. So, next what we have to do? We have to design an automata which is a state, one state. You take any state with a name. Earlier I didn't take. You take state A and state B, right. A state you take as a starting state, B state you taking as a ending state, A is a starting state, right. Now you write a transition which is a 0, right. So, now you take 0. So, now check the whether it is satisfying or not. You take 0 is accepting, 00 is not accepting, like you take like transition like this. Just I am brute forcing technique, I am taking 0. So, what will happen? Single 0 is accepting, but 00 is not getting accepted. So can I make like this double ended circle? This is also final state, right? I can make it. So 0 is accepted, 1 0, 2 0 accepted, 3 0 accepted, 4 0 accepted, 5 0 accepted, 6 0 accepted, any number of zeros is accepted. So that means that, and one more thing also you need to remember here, it in an automata it is not necessary that it should have only single state. It may have multiple states in a single automata. Multiple state, and there is a one condition that also it not necessary single final state. They may have multiple final states also may be presented into the automata. So now we see an example which is a multiple state automata, multiple state which having multiple final states, right. So now we can go for the some other example problems. So what is our objective? Our objective is ending with 0, right. But what about 1, right. So this should also accept, this should also accept, this should also get accepted. But in this and our example, there is no such kind of things are not at all present. So what we have to do? We can do for one thing, we can go for one more thing, that is so we will go for the extension of this one. Don't get confused, even number of zeros same, right. So what we can do, previous one ending with 0, don't get confused. Just I taken a PPT with some just avoid this this even number of zeros. We will discuss, this is another problem, we will discuss later on, right. So now we will take the one more example, that is same example but final version. You take the state which is A state, which is starting state, right. You take the one more state B state, which is a final state, right. It is not compulsion that you have to take A state or B state 1 2 something. You can take any number of states and any number of transition. One more thing also, it not necessary that you should have starting state only, final state, final second state, there is no such condition. But thing is that you should accept the our automata is correct, that is the our aim, right. So what is our objective? Our objective ending with 0, right. Now you take this one, transition with 0. Now you check it, one number 1 0 is accepted, right. One number is accepted. You take here transition with self transition which is 1. You take 1. Then what will accepted? What will accept? 0 will accept, 1 also will accept. That means the string ending with 1 also getting accepted. So we shouldn't take here 1 is a self loop. So can I take 0? So now check the transition, 0 is accepted, 0, again 0 is accepted, okay, 0 is accepted, 3 0 is accepted. That means I try to understand 0, second 0, third 0, fourth 0, fifth 0, any number of zeros will get it accepted here. Now what about 0 1 0? 0 1 0 string should also get accepted. So in that case what we have to do? You put a transition over here with 1 is a input symbol. So what will happen? Now you check 0 is accepted, 1 is accepted, 1 0 0 accepted, right. So you take one more input, 0 1 is accepted. Now check it, 0 1, there is no such transition. So 0 1 1 is not accepting. So now you may get out, can I take one more self loop here which is 0 or 1? If I take 0, any problem? Let me check first. 0, So now you try to check it. If it is 0, check it. 0, 0, 1, 0. It is violating the property. What is our objective? Ending with 1, 0. So property is 0. It is not violating the our property. That means that it is satisfying the condition. String is satisfying condition. I didn't check till now whether it is a automata is accepting or not. Right, now you check it. 0, 1, 0, 0, 0, 1, 0, accepting. String is accepting, automata is accepting. Check one more. Check one more, which is a 1, 0, 1, 0 should get accept, right? So now any transition is existing from starting state 1? No, it is not existing. So that means that you can insert here 0 or 1 also. So 1, 0 you can getting accepted. So in that case, what is accepting? 1, 0 should accept. So 1, 0 accepting. 1, 1, 0 should accept. 1, 1, 0 accepting. Right. 0, 0, 1, 1, 0 accepting. Yes. Now you check it. 0, 0, 1, again 1, again 0. So it is getting accepting. That means that string with starting with a string with ending with 0 is accepting, right? Finite automata design is completed. That means that it is not necessary that it should have 2 states, it should have 3 states, not necessary. There is states is not compulsion here, any number of states may be presented. But thing is that it should fill the logic should be correct. So then only it is our design automata is correct. Now we will see the one more example, right? We will see the one more example. So in that design finite automata strings over 0, 1 even number of zeros. That means that automata should have even number of zeros. Like what are the strings accepting strings? Accepting strings, what are the accepting strings? Let me write first. 0, 0 should accept, right? 0, 0, 0, 0 should accept, right? And next one is 0, 0, 0, 4, 0, 5, 0, 6, 0, etc. It should get accept, right? So what about ones? Once there is no such condition, there is no condition is existed, you can take any number of 1, you can exclude the ones also, right? Now write the some strings which is rejecting string, rejecting strings. So what are the rejecting strings? Rejecting strings, then write 1, right? 1, if it is 1, whether should accept or reject? It should accept, because of there is no such condition. 0 on 1 should get accept. Next 1, 0 accept or reject? You should not write a rejecting string, it is accepting. 1, 0 should accept, reject it, because of it is a odd number of zeros. Next 1, 1, 0 should get reject, because of odd number of zeros, right? 0, 1, 0 accept, it should get accept, right? Next one is 0, 0, 1 accept or reject? It is a reject. So it is a string, it should accept, it should not come to the rejection string, it should come acceptance string, right? So next one rejecting string 0, 0, 0, 3 zeros should get reject. 0, 0, 0, 0, 5 zeros should get reject. That means that there is no condition that number of ones, only condition that number of zeros. That means that any string in that like 0, 1, 0, 0, 1 something, etc. There is no condition that it should get a any number of ones can be accepted. only condition number of zeros. Now we will see this one in another slide. Like, see, now you see what is the condition? Even number of zeros. So even number of zeros means what is the string which is having minimum length? Double zero is a minimum length. So if you want to get accept the double zero as a minimum string, how many number of states are required? Minimum 3 states are required. That is n plus 1. N is a minimum number of input. So plus 1 states are accept. Now you see the example now. So now you take the string which is state q0 is a starting state. Take the q0 is a starting state, right? So now you take the q1 is a ending state, right? If you take the q1 is a ending state, now you put 0 is a input. 0 is a input, right? If you take the 0 is a input from here to here. Now what will happen? Single 0 is accepted, double one more 0 is not accepting. That means that odd number of zeros are accepting. So now you see here what I told, minimum strings are double zero. How many states are required? 3. It is not necessary that 3 states are required. Sometime it may require less also. You can do the same thing with 3 states, 4 states, 5 states, 6 states, any number of states. But just I told for better understanding, I told n plus 1 state. It is easy to understand, right? So now we will see the both example with 2 states and 3 states also we will see. So now you see this is not possible. So what I can do? I can do one more thing. Q0 is a state, right? Q1 is a one more state, right? Make the Q0 is a starting state, right? Q1 is a second state and make the Q2 is a final state. Just now I told now two minimum input string is 2, so that we can go for the 3 states. Now I am doing that one. Just try to understand. Transition is 0, right? So now what is the minimum state? Minimum string double 0. Now you check it. So Q0 Q1, Q0 to Q1, what is the transition? 0 is a. What is the input symbol here? Q0 to Q1, Q2, 0 is a input symbol, right? Here it is a 0, here it is a 0. So that means that 2 zeros are accepting. So even number of zeros. What is the input? Next input string? 4 zeros should get accept, right? 1 0, 2 0, you make one transition like this. So 1 0, 2 0, 3 0, 4 0. That means that 4 zeros are accepting. Now check it. Any number of zeros with even number, it will be accepted. Now you check it here. 0, 2 0 accepted, 3 0 not accepted, 4 0 accepted, 5 0 is not accepted, 6 0 accepted, 7 0 is not accepted, 8 0 is accepted, 9 0 is not accepted, 10 0 is accepted, 11 0 is not accepted, 12 0 is accepting. That means that strings with even number of zeros are accepting the strings, right? This is the 3 states automata, right? Now instead of going 3 states, can we see the one example with 2 states also? Q0 is a one state. You take this is the starting state. Q1 is a one more state, right? Now you take the Q0 to the Q1 is input symbol is 0. Q1 to the Q2 input symbol is 0. You again take 0. Again starting state becomes to the final state. You make final state also, right? So now you check it. Q0 single 0 is not accepted, double 0 is accepted, triple 0 is not accepted, 4 0 is not accepting, 5 0 not accepting, 6 0 accepting, 7 0 is not accepting, 8 0 is accepting. That means that logic these automata these both are remain safe, but Minimized automata is this one. Minimized automata is this one. So we will discuss the more details about minimization of automata in coming lectures. So that means that it is not necessary that should have 3 states. It may have less than that also, but minimized automata is unique automata. This one, what is the uniqueness of automata? We will discuss in the remaining further classes. Now you check it. So even number of zeros is accepting. What about ones? So can I put 1 here with self loop? Does it hamper any even number of zeros? Now you check it. 0, 0 accepting, 0, 1, 0 even number of zeros accepting, 0, 2, 0, 1, again 1, 0 accepting, yes, accepting. Now you check it this also. String 0, 1, again 1, 0 accepting. Now it is accepting 0, 1, 1, 2, 1, 3, 1, 0 accepting. So that means that anything is with even number is accepting. That means that it is not violating the our basic property. So now you check it the one more transition on the Q0 state with 0. Now check it. It will get accepting or not. 1, 1. What we put here? 0 na? You check it. If you put 0, what will happen? Single 0 is getting accepted. That means that odd number of zeros are accepting. That means that no need to put here 0. It should be compulsory 1. So now you check it. What is the final automata? I am writing with clear answer here. Q0, Q1, right? Q1 is not final state? No. Q0 is a final state. Q0 is a starting state, 0, again 0, right. It is 1 is a self loop. Here you make is a 1 is a self loop, right. What is the final state? This is a final state. Q0 is a final state. Now you check it. 0, 1, 1, 0 accepted, yes, 0, 1, 1, 0 accepted. Now you check it one more thing. 1, 0, 0 accepted or not? It should get accepted because of even number of zeros. 1, 0, 0 accepted. So that means this is the final automata for designing even number of zeros, right. So we will see the one more example, that is a automata with design finite automata that accept the all strings over a comma b with number of a's multiple of 3. So that means that any string which having a comma b as a input alphabet, we should accept the a's number of a's is multiple of 3. That means that a should get accept. 3 a's are accepting. So a 6 a's are should get accept because of it is a multiple of 3. So 9 a's should get accept. 12 a's should get accept. What about b? B, any number of b should be accepted. So what is the minimum string here? 3 a's. So what is how many number of states are required? Now let me check. Q0 is a taking starting state, Q1 is a one more state, Q2 is a one more state. To make a transition 0, 0, input symbol, how many a's? 2 a's. Now you can make like this also, a, or else you can make like this one more state. You can make this is the final state. 3 you can iterate like this, or else you can do Q0 Q1 like this also you can make. So starting state is a final state, right? Now you check it, single A, double A, 3 A's are accepting, 4A, 5A, 6 A's are accepting, 7A, 8A, 9 A's are accepting, 10 A's, 11 A's, 12 A's are accepting. So that means the string which is going to the final state, it is getting accepting, right? So now what about B? Finite automata with B. Here AB is there. What about B? Can I put B here? Does it have any problem? No. A, B, A. Still it is, A is multiple of 3. So can I put like this here? B, does it have any problem? No. B, A, no problem, still it is working. So that means that this is the automata which will can construct A's multiple of B's, or else we can do some more also like this, one more automata like this. Take this is the one state, this is the one more state, this is a one more state. So this you take the starting state and final state, make the transition like this, A and A. It is similar like say, but it is slightly different. Make this is a self loop B, this is a self loop B, make the self loop B. So this is also correct. So you can do any way, either it is same but slightly different. So it will be either of way you can do. So which this is we already done, right? So find the language acceptors are finite automata. So I am writing one example. Try to find the automata. Q0, Q1. So Q0 is a starting state, 0, 0. You make the Q1 is a final state. So what is the language acceptance? What is accepted right down here? 0 is accepting, double 0, 0, 0 is not accepting. So triple 0 is accepting, yes, 0, 0, triple 0 is getting accepting. 1, 2, 4 0 is accepting, check it, 1, 2, 3, 4, no, 5, yes. That means that 4 0 is not accepting, 5 0 is accepting. That means that what you can conclude, 1 0 is accepting, 3 0 is accepting, 5 0 are accepting. Now check it one more, 1, 2, 3, 4, 5, 6 is accepting, 1, 2, 3, 4, 5, 6, no, 7 accepting. So 7 zeros are accepting. That means that odd number of zeros are accepting, right? So this is the language accepting. That means that here L is a language which is a odd number of A's over epsilon equal to delta equal to a comma 0 comma 1, not a comma 0 comma 1. Not necessary 1 it should include, it may include, may not be included, right? So this is about today class. So I can give one more example also, you try it, this is at your as a exercise. So I am taking A is a one state, B is a one state, A is a starting state, C is a final state. Make it C is a final state. A, you make this is the B. This you make A is A R B. This is the one automata. You find the language. So don't worry about this one. Just I am given exercise. So don't concentrate this. Try to do this exercise. We'll discuss one more. I'll write one more. Q naught, Q, Q1, Q2, Q3. Q naught is a starting state. 0, 0, 0, 0. So make this is a final state. So try to find what is the language over the sigma over 0 comma 1. You make this is the 1, this is 1, this 1. You try to find what is the language. So this is a exercise for you. So right, what we discuss in today class? Today class we will discuss the examples of finite automata, right? So what is the first one we discuss? We discuss the first one, finite automata, strings that accept all strings over 0 comma 1 ending with 0. This is the first one we discuss, right? Second one, what we discuss? Design finite automata that accepts all strings over with even number of zeros, right? Third one, design finite automata that accept all strings over 0 comma a comma b with the number of a's multiple of 3's. So this is the 3 problems we discuss in the today class. So thank you for watching. We will discuss in the remaining topics, like so as we discuss in the initial section, right? That is like transition table, transition diagram and example problem. We will discuss in the remaining classes. Thank you for watching. If you like the content, subscribe my channel, share to the needy people. Thanks for watching.